All right, ANP2 students, we're going to continue on with regulation of the glomerular filtration rate. So the last video we talked about the myogenic response and the tubuloglomerular feedback mechanism. So those were things that were the kidneys themselves actually regulated. So they called it renal autoregulation since they didn't really need any other systems to help them. But sometimes these two only worked when we had a kind of a normal homeostatic range in our blood pressure. So the level or the numbers they used were for mean arterial pressure. So anything between 80 and 180 was the mean arterial pressure, where these mechanisms would generally be sufficient to maintain glomerular filtration rate in its normal at its normal level. But sometimes we have more significant changes in our body that go beyond those blood pressure levels and blood volume levels. So then we have the nervous system and then an endocrine or a hormone that's going to help regulate glomerular filtration rate. So there is a picture. Give me a second here, I forgot to pull it up. Oops, I think my apologies. There we go. So they have these nice big pictures. Oops, if I can get them up there. Keep them there. Okay. All right, so this is a nice little concept map to kind of help you remember the role of the sympathetic nervous system in regulating the glomerular filtration rate. Okay, so this is a system, the sympathetic nervous system will help with the glomerular filtration rate when we have like a situation where we'll use, they gave a couple examples, but we'll use where a person maybe has severe hemorrhaging and then they've lost a lot of blood volume. And so when they've lost a lot of blood volume, we don't want them to lose any more, especially through the urinary system. So that's one area that we can rely upon to make sure that we don't lose any more water from the body because of that severe hemorrhage. So this stimulus, stressor / emergency, we'll use severe hemorrhage as an example. When that happens, the sympathetic nervous system will send a nerve impulse to the kidneys, and it'll have two effects. The first effect is it's going to go to those afferent arterioles, and specifically flip this up a little bit, specifically those smooth muscles in the wall, and cause them to vasoconstrict even more than they can on their own. So they will vasoconstrict, will get increased resistance and reduced blood flow into the glomerulus, and that'll slow down the glomerular filtration rate. And in this case, since we have severe hemorrhage, we've lost a lot of blood volume, we don't want to lose any more extra fluid. So in this particular situation that's not normal, the glomerular filtration rate is going to decrease and we'll get less filtrate going on in there. Now the other role that the sympathetic nervous system has, those little granular cells, one of their functions that we talked about in a couple of videos ago is that they release renin, which is an enzyme. And so when they release renin, the sympathetic system will tell them to release renin. That renin goes into the bloodstream, and it will kind of kick off or start to initiate a chemical reaction that ends in the production of angiotensin II. So if you guys remember, angiotensin II, I think I pulled this up. Angiotensin II was one of those three hormones we talked about, that their role was to increase blood pressure. And of course, in this case, if we're having severe hemorrhage, we'd want to do that. So how the angiotensin II does that is it's going to stimulate those mesangial cells and it's going to cause them to contract, and then that will decrease the surface area of the glomerular capillaries, so there'll be less area for any filtrate to leave. So with this vasoconstriction of the afferent arteriole and the mesangial cells contracting, we get a decrease in glomerular filtration rate. So we wouldn't lose as much of our fluid, and we would try to get our blood volume back up, which will also help increase our blood pressure. Again, if we're in a state where it's an emergency, we have hemorrhage. Another example the book gave was if you're running a marathon on a really hot day, so you're doing some sort of like, excessive or very strenuous exercise. Again, your body doesn't want to, needs to conserve all the fluid that it needs. So that would be another reason why this might, this process regulating glomerular filtration rate might happen. All right, so that's for the sympathetic stimulation. So then the opposite could happen. We could have a situation where we have the increase in blood volume. This might occur with heart failure, liver failure. There's probably, some other causes, but essentially we have an increase in blood volume, and that'll also increase blood pressure as well. And so we need something to get our blood volume and our blood pressure back down into the normal. And so we're going to get the blood pressure back down by decreasing the blood volume. That's how we'll affect the blood pressure in this case. So if you remember, the atrial natriuretic peptide, ANP, was the hormone that will decrease blood pressure. So that was its role. It was the only one that we talked about with the last chapter that will decrease blood pressure. The other three all work to increase blood pressure. All right, so the atrial natriuretic peptide is called that because it's located in the right atrium. And the right atrium receives all the blood from the body, so it's a good, the cells in that area that produce the ANP hormone, they're in a good position to detect if there's increased blood volume, thus increased blood pressure. So if they feel that stretch, they will release the ANP hormone. So this is one of the, or actually I think it's the only hormone the heart releases. And that hormone will go to our kidneys, specifically the afferent arterioles, and it's going to cause the granular cells, the little smooth muscle cells of the afferent arteriole, to relax, and we'll get a dilation of the afferent arteriole. That'll cause more blood flow, less resistance, more blood flow into the glomerular capillary, and that's good because that'll cause more filtrate to be formed, increase our glomerular filtration rate. The other part of the ANP hormone, it also will inhibit those little granular cells so they won't release renin, so we don't get any angiotensin II, which is good. So those little mesangial cells, they'll stay in a relaxed state and increase the surface area. So those two things, dilation, vasodilation of the afferent arteriole, and the relaxation of the mesangial cells to increase that surface area, will increase that glomerular filtration rate. And so if we have an increase in glomerular filtration rate, we get a lot more filtrate moving through the tubules, and we'll get a lot more loss of the water. And so that should help decrease our blood volume, and thus that'll help decrease blood pressure too. So we have some sort of disease process going on that's affecting blood volume or blood pressure. This is a response of the body to try to maintain that blood volume and blood pressure back to where it needs to be. So, all right, so that is the video on regulation of glomerular filtration rate by the nervous system and by endocrine system, or the endocrine's role in it. All right, and I'm going to do another video, so I'll see you in